Welcome to all. Now we are going to study about Introduction to Lattice. A lattice is a partially ordered set L, less than or equal to, in which for every pair of elements A, B belongs to L, greatest lower bound and least upper bound exist. Greatest lower bound of A, B is defined as A star B or A and B or A dot B. Similarly, least upper bound of A, B is A ring sum B or A or B or A plus B. Let us check the properties of lattices. Now we are going to check the property which is called as isotonicity property. Isotonicity property. Before entering into isotonicity property, we know that when A less than or equal to B, you have to remember this, when A less than or equal to B, A and B is equal to A and A or B is equal to B. So using this basic result only, we are going to prove the isotonicity property. The statement for isotonicity property is let L, and R be a given lattice. So for any A, B belongs to L, A, B, C belongs to L, we have B less than or equal to C implies the first condition is A and B less than or equal to A and C. Similarly, second one is A or B less than or equal to A or C. Now we are going to prove this one. For that, instead of proving A and B less than or equal to A and C, it is enough to prove that greatest lower bound of A and B and A and C is nothing but A and B. Or we can also rewrite in the form of A and B and A and C is equal to A and B. Let us consider the left hand side. A and B and A and C, which is equal to, by associative property, I can able to rewrite this one as using associative. Next one, using commutative, I can rewrite this one as A and B and C, which is also equivalent to A and B and C, which is equal to A and B and C. We know that when B less than or equal to C, using the idempotent condition, we can able to write when B less than or equal to C, B and C is equal to B and B or C is equal to C. So from that one, B and C is equal to B. Therefore, A and B and A and C is equal to A and B. Therefore, I can be able to write A and B less than or equal to A and C. Next one, similarly, we are going to prove it for A or B less than or equal to A or C. Second one. That is, we are going to prove that least upper bound of ARB, comma, ARC is equal to ARC. Instead of proving this one, I can able to write this one as ARB or ARC is equal to ARC. Let us consider the left hand side. ARB or ARC. By using associative, we can rewrite this one as BRARC. And using commutative, we can rewrite this one as ARB RC, which implies ARA or BRC is equivalent to AR BRC. We know that when B less than or equal to C, B and C is equal to B and BRC is equal to C. Therefore, BRC is nothing but C. It is ARB or ARC is equal to ARC. Therefore, I can able to write A and B less than or equal to A and C. The isoternity property is satisfied. Thank you.